My dearly beloved, geeks, geekettes, corporate bastards, and blue-eyed spooks, love thy neighbor. And if you do, try to do it with her consent, and try your best not to go to jail because of it. The story that I'm going to tell you today benefits from Schrödinger's disclaimer. It may or may not be based on real facts. For the purpose of privacy, the names may or may not have been switched with real people or with actual people. So any resemblance to any kind of people that you may or may not know is purely coincidental. A bit about myself. I guess my core competence is not hacking. My core competence is evangelism. I like to talk, to the exasperation of some of my friends and colleagues. I'm a product manager. I build stuff. I create stuff. I do infosec as a hobby, and I've been doing it since, I don't know, since that FTP server in Red Hat was the surest way to get root on a server, if you remember, in 1990s. And it's my second presentation here at DefCamp. We will work under the assumption that we are on the same network with our next door neighbor. And, well, we're going to see things that we can do on the same network. So you can sniff, you can do man in the middle, you can do SSL in the middle. As we've seen 2 years ago, you can do it very nicely by downgrading HTTPS to HTTP in order to, to prevent the victim from noticing that anything wrong is happening. We can redirect traffic. We can inject HTML code in web pages. We can do DNS spoofing, redirect any kind of request to our own servers. But ultimately, for the goal of today's presentation, we want to own the box. Tools. We're going to be using Ethercap, burp / OWASP, Zap, any one. Either of these is okay. The backdoor factory, for those of you who don't know it, it's something that we're going to talk about in a bit later on. And a lot of patience is required if you want to do a good job in talking or getting or spying on your next door pretty neighbor. So the first thing that you need to do, of course, you set up Ethercap, you ARP hijack her connections. However, the first thing that you need to do is stop right there and listen. As I keep saying over and over again, in order to be successful as a pen tester or a hacker, you need to be as discreet as possible. And you need to make sure that your target doesn't notice that you're doing anything to her or him or whatever. So the first thing that you do is listen. Try to study the traffic. In this particular case, we want to look for applications that are querying updates, and we're going to try to hijack the updates. This is how traffic looks like in burp, right? So you can see, for example, an application called YouTube Downloader making an update query and getting a reply from the server. The latest version is whatever. So I stood on the network, I listened, and at some point, I saw this. Samsung Kiss, a highly popular application that comes with all Samsung phones, made a request to check if it has updates. Now, the problem was that it was a plain text query. So what can we do with plain text queries? We can rewrite them. I picked Samsung Kiss because it was the easiest one. One of the key takeaways from this presentation is that this attack works with almost all applications installed on Windows systems, or not necessarily just Windows, as long as they don't validate and they don't secure their updates. So you take the software that you want to, to hijack, you put it in a lab, you try to get an older version to see how the update mechanism works, how the replies from the server look like, how the application treats those replies. So we can see that an up-to-date keys, gets a reply that ends here. Current version is 14.113.3, and it ends there. An out-of-date keys gets current version is something, but the latest version is whatever. Now, an interesting thing in this particular case, which makes Samsung laughable, first of all, the version that I got, the outdated version, I didn't have to look for it because the version on Samsung's website was already outdated. And the second thing is that download URL over there. If you can see it, it's right down there. And I said they couldn't be that stupid. I mean, they couldn't say that the URL where the application gets the download is sent in plain text as a configuration for the update or whatever. However, as it turns out, if we replace on the wire that string that said, current version ending in 113, if we continue it with whatever we saw, it was the, with that thing at the bottom, so with something that looks like that, but we increment, the version number with 1. Well, this is how one of these rewrites rules would look like in burp. I hope you can see it. So replace anything that you see coming down the wire that looks like the update server saying there's no updates, replace it with the update server says that there are updates, and you can get them from 10.025/ks.exe, which of course is on my server. And I prayed to the gods that this wouldn't work. Unfortunately, well, it did. And even worse, you can see my web server serving the file to the keys application, which was sad. So what now? The point is that we can deliver anything. You can deliver your own backdoor, your own whatever. Any kind of executable will be executed by the keys updater. But if you deliver something, a backdoor, keylog, or whatever, the keys updater would probably crash, right? Or it will execute your payload, but it won't move forward. And as I try to say over and over again, we don't want our victim to notice anything is wrong, right? So here comes Backdoor Factory. The Backdoor Factory is a very nice tool wrote by some guy called Joshua Pitts. His Twitter name is Midnight Runner, and his GitHub repository is Secret Squirrel. Backdoor Factory is able to inject a payload into a binary file. It supports portable executables, it supports ELF files, it supports even Mac files, Mac-O, the Mac binaries. And it uses a concept called code caves. In a binary file, it's not filled with data from top to bottom. It has various zones where you can inject things because they're empty. So it supports local patching, which gives you a lot of flexibility. You can fine-tune a lot of things. You can set a lot of options. And it also supports an on-the-wire module that will automatically patch any kind of binary that's being downloaded by a system with your payload. However, this is less reliable. It's quite unstable. It crashes every now and then. And the payloads tend to be detected by the antivirus. And of course, since this is a high-tech security conference, we're going to work with full shields on, fully updated antivirus, so we can do it like a real-life scenario, right? And so it supports Metasploit payloads, which is what we're going to see today. So what I did, I got the legitimate KS update from the KS website, which is from CloudFront, whatever, but it's the actual KS update, right? I patched it with the Backdoor Factory with a Metasploit payload, and I moved it in my web server's directory in order to deliver it to my next door neighbor. So this is basically how the backdoor factory looks like. It can detect some areas that support your code size, your payload size. In my case, it was, I don't know, 679 bytes. And if it can find areas within the PE file where it can fit that code, it's going to rewrite the entry point and everything in order to execute your payload along with the actual PE file. So I hereby raise a humble prayer to the demo gods in order to see this in action. So here we have a Metasploit handler that's waiting for a shell. And let's hope we don't disappoint it. Any questions until Windows boots? Well, as you know, for the few people in this room that know me, they know that I'm a very, very shy person, and I'm just simply scared and terrified of women. So, okay, so the Windows system has booted. This is her desktop. And keys is set to start when the system starts. We're going to wait for the, for the full system to start up, for the antivirus to kick in, and everything to be in the most natural form possible. Okay, so keys started up. It's a very slow system. I'm sorry. And it's also Windows, so. Okay, now, oh, she's logging onto Skype. Okay. Ay, demo gods. In theory, keys should have updated itself, but apparently it's lazy. Oh, it's because it's frozen. Or because it doesn't work. Okay. For some reason, well, the demo guys are against me today. You know, one of those things where you try it like a million times and it works, and then when you have to demo it on stage, it doesn't. Oh, wait, I think I know why. It may be that I don't have an internet connection, because I can see the requests, but I don't see the replies. So there's nothing to, there's nothing to rewrite in our proxy. So let's check for internet. She's a genuine person, she has a Gmail account. Oh, crap. Oh, there we go. Slow internet. Voxility tried to kick me in the ass, but ultimately truth prevailed. So let's see what happened here. As you can see, the reason it didn't work is it was making the request, but it didn't get a reply from the server. So that means that the internet connection had some issues. However, when it did get a reply from the server, this was the original response. So the server said, okay, and it ended here, and we rewrote it with current version, blah, blah, latest version, 3.2.4114, and download URL, my URL. Now, on her system, well, we're going to update, and let's see what we'll see. It looks like a legitimate keys update, doesn't it? If you know keys. Well, look. Samsung keys install Shield Wizard. This will install the latest version of blah, blah, blah. So it is the actual keys installer. However, back in Wonderland, let's see. Ta-da! Okay, so do we have time to play a bit with Meterpreter to see a few things that we can do with the system now that we're in? Well, let's see. No. We're going to try to gather the Chrome passwords. Downloading, blah, blah, downloaded cookies, history, login, bookmarks. Decrypted Sasha Gray. Decrypted Marina Hansis, her Twitter account. Oh my God, will it actually work? That would be so cool. Well, of course it does. I set it up, everything, so. And also, one of the latest additions to the Meterpreter is a thing called LastPass Credentials Manager. So LastPass, oh, by the way, in case you didn't notice, we've managed to run our payload on a fully updated antivirus. So its latest updates, 29th of November. So, where was I? Yeah, so LastPass Creds. LastPass is another company that I'm not particularly fond of, because I'm not particularly fond of storing passwords in the cloud. So we're going to try the LastPass Creds extractor to see if it works. In theory, it shouldn't. However, oh my God, this cannot be so. So new tab, Chromium, LastPass.com. So just for the sake of it, we're going to log on and see that that module from Meterpreter from Metasploit actually works. So what was it? marina.hansis@gmail.com with I love Brazers. Oh, look. It is beautiful and full of passwords. Yeah, Marina, she's a gamer. So, okay. And just for the sake of it, the update works. It's going to get installed, keys will restart, and everything works. So back to the presentation. Other methods, of course, there are millions of ways, probably an infinity methods to quote somebody, to own a box, of course, especially if you're on the wire. Another method is if you're lazy, you can just leave the backdoor factory running on the wire. It's going to try to patch all the downloads. The only downside for that is that the proxy from the backdoor factory is not that flexible. You cannot select the areas of the binary where you can put your shellcode. It usually just appends the shellcode at the end of the binary, and that makes it very easy to be detected by antivirus solutions. So you need to fiddle with it a bit. So I've kept in contact a bit with Joshua, and he told me that he's going to work on improving it in the future. You can gift her, of course, a pre-cooked Android phone where you can put your backdoor and say, Marina, I got you a phone. It's an expensive one, so use it well. You can, of course, use your charms, and good luck. So final notes. Everything that I've done was done exclusively on plain text traffic. No SSL main in the middle, absolutely nothing that would be too aggressive, so to speak. So anything that would be too intrusive or no kind of anything, just plain text traffic. Unfortunately, over 80% of the applications installed on a system performed the update query over an unencrypted channel. Samsung Kiss is just one example because it was the easiest one to hack into, but most other applications if you take the time to understand how they update, how they validate their updates, can be hacked in the same way. And this is the state of the internet. 99.99% of all downloads worldwide are done on plain text protocols, so you can tamper with that very easily. A very small percentage of the applications actually try to validate their downloads. For example, microtorrent. Or when it queries for an update, when the server says that there is an update available, the update wouldn't get applied unless it matches a certain checksum, right? So there's actually several checksums that the update needs to meet in order to be applied by the client. Unfortunately, the checksums are being delivered in plain text along with the update response. So the microtorrent asks, do I have any updates? And the server says, yeah, sure you do. This is the update, and make sure that it has this checksum, okay? And yes, of course, you can rewrite that information with your own checksum, and the microtorrent client will believe you. Any questions? Lucian?
I have a question about like the particular LastPass password, master password theft, because you said that LastPass is storing passwords in the cloud. It's not actually storing them in the cloud. It stores an encrypted blob in the cloud, which is downloaded to your browser, and the decryption is done in JavaScript locally. So it uses a zero-knowledge model. They never have access to your password. So why you were able to steal the master password is because you stole it from the actual computer memory, because she left her LastPass session on, or she saved the password locally or something like that.
Unfortunately, the Metasploit, I mean, I know, so that's true. You know, LastPass doesn't have access to your passwords, definitely not, so let's be fair. However, in this particular case, she didn't have the LastPass loaded in, I mean, the system was just booted. So the Metasploit module can extract the LastPass master password easily as pie without having it, I mean, without starting, maybe, I think LastPass probably has something that starts at startup, I don't know. But that module was run on a freshly booted system. So it's kind of sad that it can be extracted.
Yeah, I mean, that's what I'm asking. Where did it get it from? Did it get it from memory? Did it keylog
I don't know.
when it was typed in? Was it saved locally? Is it able to crack the password for the encrypted? But that would be bad, obviously. There are some things like you can use two-factor authentication with LastPass, in which case you wouldn't use the password anyway. But
the answer to your question is I don't know, because I didn't argue with it. I didn't look into the Metasploit module. If you, I mean, you know, it's open source, you can look into it. I personally didn't, so I don't want to lie to you saying, you know, it does this and that.
Because I assume if it works with LastPass, it works with any password manager, and it works with any potential encryption application that stores the key in memory.
Again, if we look together after this into the module, into the Metasploit module, we're going to see how it does it. My guess is, unfortunately, that it does it probably the way it does it with Skype. You know, the Skype password is hashed, is salted into a config file.
Okay.
So I'm going to guess that LastPass has some sort of a config file as well, where the password is hashed, probably not salted, and it can be cracked. But not easily cracked, because I love browsers, by the way. It's not in any MD5 table I've looked for. I've checked, you know, I've checked whether or not the hash, the MD5 hash.
Yeah, and there's no brute force because it did it instantly. So
yeah, so there's no brute force. So it's definitely something to be looked at, to the way, you know, that Metasploit module can extract so easily the LastPass credentials.
Okay, thank you.
Have you tried with a premium antivirus version, because I saw that you used Avira free, or have you tried to upload the file on a website like VirusTotal to go through all the detection engines to see if your payload is detectable at all? That's my first question. And my second question, have you tried if you can log into LastPass with the cookies you download if she has two-factor authentication enabled?
So the answer to the second question is The last pass was just a gimmick. You know, there's a million things you can do once you have a Metapreter shell on the machine, and I just picked 2 Metasploit modules for the sake of the demo. Of course, if she does double authentication, won't be able to log on with cookies, without cookies, whatever. And the answer to your first question is, yes, I've uploaded the binary to VirusTotal. I got about 3 Metapreter sessions, one from Kaspersky, one from I don't know who else, because they actually run the binaries into their machines, and if it executes, well, it gives you a temporary Metapreter shell, and you can look inside their testing machines for a bit. Well, you know, I don't want to, least of all, I don't want to bash at antivirus solutions, okay? I'm not going to say that that solution detects it, that solution doesn't detect it. The point is that some solutions don't detect. I mean, all solutions detect Metasploit payloads, absolutely everybody. However, if you insert the Metasploit payload in the binary using the backdoor factory local patching, then it's significantly much more difficult to detect. And I'm not going to say which antivirus do detect it and which antivirus don't, because it wouldn't be fair.
Okay, and in the list of updates you tested for, have you included even antivirus updates?
Yes, when I did the research, I did it with WebRoot installed. And unfortunately, I didn't have the time. It's, again, Kiss was easier, or MicroTorrent or whatever YouTube downloader were significantly easier to study and to hijack than the others. My guess is that, you know, WebRoot was querying for an update on SSL, and it was receiving the updates via plain text. And I don't know how they validate the updates, whether or not the key, the key used to validate, because I'm going to guess they don't use MD5, you know, I'm going to guess that they use PGP or whatever. If they have the key hard-coded into the product, then it's game over for them. If they have the key exchanged in real time for that update via a secure channel, then that's okay. But I don't know, I cannot tell you for sure because I didn't have the time to look at absolutely everything.
Thank you.
That's it?
One more question.
So I saw that you're using the updates to inject your executable into the updates, and you're blaming basically the software that does not have various checksums and stuff like this, and the antivirus that does not detect that. But I actually consider this operating system issue. I saw you, for example, using Debian. Debian uses PGP for updates for all the packages. Ubuntu checks them also. Windows does not provide a way to update your software, and that's the actual problem. Because, for example, on Windows, Chrome updates with Chrome Zone Update System, Firefox the same, keys the same. The whole list of applications re-implements everything.
You're partially right. So first of all, one fun fact, Mozilla and Adobe Reader. Adobe Reader was, of course, my first target, you know. Java was my second, but Java was significantly way too easy. I mean, Java was way too easy, nothing to... Adobe Reader and Firefox update in small chunks of packages, much like Microsoft's CAB files, but that's very tough to get into. I mean, they're not packed. It's like a multi-part message that's reassembled by the updater, which is pretty cool on their behalf. So, yeah, Chrome, Firefox, Adobe Reader, props to their update system. Adobe Flash, not so much. And to your first question, yes, the problem is the package manager. I mean, in Linux, and wherever there's any kind of store, any kind of repository for software, of course, everything is much more secure, but you know, you can't find everything in repositories. Every now and then you download something. Every now and then you install something. And not to mention that applications, even though you install them from a repository, will check for updates, even on Linux. And if that update query that they perform is bad, is written poorly, is coded poorly, is designed poorly, you can trick it to update from your server rather than updating through apt-get. Maybe there's an application on Linux, I don't know, I haven't studied, but there's an application on Linux that queries for an update, and through the update mechanism, you can tell it to update in a different fashion than DPKG. He's saying that on Linux.
On GNU Linux operating systems, apps do not update themselves as on Windows, but the operating system updates the whole thing. So updates each application. So that was basically the weak spot that you used on Windows, which I think would be pretty difficult on a GNU Linux operating system.
In most cases, you're right, but I wouldn't be so sure. You know, I like to keep a certain level of uncertainty at all times, and it's something that I would recommend to absolutely everybody. We should always be afraid of the things we don't know. Please.
Someone just sent me, Bogdan Alekus just sent me a description for the Metasploit module that targets LastPass. So it reads like this: our attack only covers users that click the store my password option, though, so don't store your master password.
Okay.
Obviously.
Behind you.
Yeah, I just want to comment on the Linux thing. For example, the Flash player, it's a 7K RPM or package that calls download of an exe.
Excellent example.
So that would be troublesome for your Linux distro. Also, I want to ask you how would you own a Mac?
Well, App Store, it's something that I've fiddled with it in the past. I mean, other than being able to plant a root certificate on the system and man in the middle, the encrypted traffic, there's not much you can do about the App Store. However, if you are able to plant a root certificate on the system, then you can own everything. But I haven't played with the Mac. The Flash player may work, you know, because it's the same thing. It's a stub that downloads the Flash kit from the website. And yeah, the Backdoor Factory supports Mac recently. Joshua recently added support for Mac O files, so you can patch those as well.
Okay, and also can you comment on how hard it is to get on the next neighbor's network?
That would have been such a significantly longer. You can try to hijack the Wi-Fi.
Like
You can ask her. You can actually ask her. I mean, this is what I would do. I wouldn't try to hack the WASP. I wouldn't try to hack the Wi-Fi. I would actually knock and say, you know, rather, do you have some sugar? Do you have some bread? Can you give me can you give me access to your wireless for just a second because my internet is down or whatever? And then why wouldn't she?
Okay, unfortunately, we are out of time. Thank you so much for your presentation.
Thank you.